Hey, what's going on? It's Justin Dickmeyer from engineerintrainingexam.com, and in this video we will review power functions. There are some essential rules of power functions that we must be familiar with in order to greatly simplify the solving of complex equations. A power function takes the form y is equal to a raised to the x, where a is known as the base and x is known as the power or the exponent, both interchangeable terms. Now, when given a power function and that power function strays away from this standard form, we can dig into our bag of tricks to simplify using a list of rules. The first rule is the power of products. Say we are given a power function where the base is made up of a product of two numbers, say a times b, and that base is then raised to the x power. Given a function in this form, it can be rewritten as a raised to the x times b raised to the x. Now, if we're given a function as a product of two power functions of the same base being raised to different powers, such as a raised to the x times a raised to the w, this can be rewritten by taking the exponents, adding them together, and setting them against the common base. So in other words, we can rewrite this as a x plus w. Now, what if we're given a function where one power function is being divided by another power function of the same base? Similar as before, say we have a raised to the x divided by a raised to the w. Well, the rule here is that this function can be rewritten by taking the exponents and subtracting them from one another and setting that against the common base. So in other words, you can rewrite it as a raised to the x minus w. Now, if the base in itself is a power function and is raised then again by another power, say a raised to the w, and that's raised to the x, this can be rewritten by multiplying the exponents together and setting it against the original base. So in other words, it can be rewritten as a raised to the w times x. Now, all these rules right here, we're dealing with positive exponents, but all numbers are possible in power functions. So let's look at the special cases when the exponents are equal to 0, 1, or negative, or even non-integer rational numbers such as fractions. So first, we can note that any base raised to the power of 0 is 1. So if the rule here, the special rule, the power of 0, if we have any base and it's raised to the 0, that is going to be equal to 1. Now let's talk about the power of 1 rule. Any base raised to the power of 1 means that that base is being multiplied only once by itself. So that means that a raised to the 1 is equal to itself, a. It's only multiplied once. But what about negative numbers? How do we deal with negative exponents? Well, we determined that when given a function where one power function is being divided by another power function of the same base, if you recall ax divided by aw, that the function can be rewritten by subtracting the exponents and setting them against the common base. So in other words, ax minus w. So we've already established that. But what happens when W in the denominator, the power in the denominator, is larger than the power in the numerator? Well, since the larger exponent is on the bottom, it shouldn't be a surprise that the base raised to a negative exponent can be rewritten as a raised to the, say, negative w is actually rewritten as a over, 1 divided by a raised to the w. So in other words, we can quickly illustrate this. Let's say that we have a squared divided by a to the third. If you just expand this out, that'll be a times a in the numerator, and we got a times a times a in the denominator. And now common terms cancel out. So we got two a's on the bottom that cancel out two a's on the top. One remains on just the number 1 remains on the top. And so now we have 1 over a, which is also equivalent to a to the negative 1. So now lastly, let's look at the dreaded fractions. When a base is raised to a fraction, let's say 1 to the n, for definition purposes, that function can be rewritten as the nth root of a, such as, say, if we have a raised to 1 to the n, can be rewritten as the nth root of a. But the fraction doesn't have to be 1 over some variable. It can be anything such as 2/3 or 5/6. So let's generalize this by saying that if we are given a function raised to mn, a raised to the m over n, then that function can be rewritten as the nth root of a raised to the m. So that's going to be our general equation. So if we're given any function, let's just look at one real quick. Let's say we have 5 raised to the 1/6. Well, that can simply be rewritten as 6, the 6th root of 5 raised to the 1. And once again, that 1 could be 3, it could be 4, 5, whatever number is on top. It doesn't have to be 1, that's just m. So lastly, I want to touch on one particular base which is of singular importance in math, and that is the transcendental number, or e, which is written as e, and that's equal to 2.7182 and change. It keeps going. This base shows up naturally in calculus because the power of the base is equal to its own derivative. So in other words, if we're given the function e to the x, the derivative of that, dy dx, is also equal to e to the x. The base power e function, e to the x, is called the exponential function and is sometimes abbreviated as exp, such that e sub x is equal to exp x. So you might see the exponential function written in either of these two ways. So that will wrap up the review of the power functions. If you guys have any more questions or concerns, or you have any feedback, or you want to see any particular video tutorials or reviews included on my site, don't hesitate to head on over to engineeringtrainingexam.com and shoot me an email through the contact, or go ahead and sign up for my free Engineering Training Exam EIT Preparation Bootcamp. So for now, you guys take care. We'll be talking soon. Alright, bye.